Video, we're going to talk about translations. Before we get started, let's do this question together. We are trying to map the blue square onto the red square. One way we can do that is with a reflection. Remember, our reflection is a mirror image with equal distances on both sides of the line of reflection. So the line of reflection here would be exactly in the middle of the two objects, and that's a vertical line. So it has the equation x is equal to a number, and that would have the equation x is equal to -6. Remember, a lowercase r stands for reflection. When you're describing a reflection, you need to mention what the line is that it's being reflected over in order to have a complete response. Okay, let me get rid of this so we can name another kind of transformation. Let's talk about translations. So a translation is when you shift or slide a figure. And I see that we can shift it to the left. The question is how many units, because we need to get super specific when we're describing transformations. So we want to get into the habit of being specific with how many units we are shifting. You might think 2 units. It looks like from here to here, it would be 2 units. But this point is on the bottom left of the square. So it needs to map onto the bottom left of this square. These are actually the corresponding points, not these two, if we're shifting it or translating it. So that would be 1, 2, 3, 4. Oops, my bad. There we go. 1, 2, 3, 4. This one would need to map onto here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we would need to translate this shape to the left. That's along the x-axis. So that would be 4 units to the left. And when we're moving to the left, we're moving towards the negative numbers on the x-axis. So I'm going to use -4 to indicate that we're moving to the left. And we're not shifting up or down. So that is 0 spaces on the y-axis because we just moved to the left. A translation is when you shift or slide a figure along the x and or the y axis. It could be both, it could be just one, doesn't matter, it's shifting the object. So translations are rigid motions, they make congruent figures. So since a figure before and after a translation will be congruent, translations do preserve angle measurement because we know that congruent figures have congruent corresponding angles. And it does also preserve side length because if it's making congruent figures, the side lengths of the pre-image and the image will be congruent. And the last thing that translations preserve is orientation of a figure. Since you're not flipping it or turning it or doing anything like that, since you're just moving or sliding an object or shifting it, it's going to be facing the same way as the original. And you can take a look at this visual over here. It indicates that we are sliding this red figure down and to the left, each of the points, in order to get to the image. Notice how the two figures are exactly the same at the end. They're congruent and they're facing in the same direction. The orientation was not changed. Before we do some of the questions today, just some notation. So when you see this little open circle symbol, that means we're doing a composition of transformations. That means a series of transformations or a sequence, one right after another. We read this backwards. So this would be the transformation that we would do first, followed by the one to the left. Let's take a look at the first question. Let me make this a little bit bigger here. Let me move this so you can see it. Let me take a second and graph what it's asking us to look at. So what the question's asking us to do is to translate, capital T stands for translation, this figure 8 units to the right, because that's a +8, that's the x-axis, so that's 8 units to the right. Let me put that down. And that's the movement on the y-axis. So that would be 4 units down. I'm going to take a point and shift it. 1, 2, 3, 4, 5, 6, 7, 8 to the right. 1, 2, 3, 4 down. Here I have y prime. Let me shift to z. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. And let me shift X. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Let me connect that all together now. Here I have X prime. Here I had Y prime. Oops, I did not connect that together good. So that's Y prime, X prime, Z prime. There we go. That looks a lot better. When you have all these marks on the diagram, it's hard to see what I'm actually doing here. So I have the coordinates. I can write them down over here as well. X prime would be 4, -2. Y prime would be 4, 1. And Z prime would be 8, -. Okay. If P prime, so that prime means that's the image. So that's after the transformation happened. So that's P prime, that's the image. That's the result of the transformation. And the transformation that happened is a translation, 1 unit to the right and 3 units up. So that's 1 to the right and 3 up. So in order to find the point that this started as, I'm just going to do the reverse. I'm going to go 1 to the left and 3 down. So 1 to the left, 1, 2, 3 down. That is the point 1, -2. And let's test it out. If I do the translation 1 up, oopsies. If I do the translation 1 to the right and 3 up, I do get back at the correct image point. This is the point that we're looking for, the point 1, -2. Now, if you didn't want to use a grid, you could have subtracted 1 and 3 from the x and y coordinates. 2 minus 1 was 1, and 1 minus 3 is -2. Here, if you didn't want to do this graphically, you could have added 8 to each of the x coordinates and subtracted 4 from each of the y coordinates, and you should get the same coordinates. Okay, let's move on over here. So here we have the point 3, -2, and that's point A. And it says first, we're doing a translation, 6 to the left and 4 down. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And then it says we are doing another translation, 2 to the right and 1 up. So I'm going to take my image after the first one and I'm going to apply the second one. 2 to the right and 1 up. And I'm going to call that a double prime because 2 transformations happen to it. And that would be the point -1, -5. Okay. Over here, we have a reflection over the x-axis. So let me take my point, -2, 3, and let me reflect it over the x-axis. So here's the x-axis. So that's 1, 2, 3. 1, 2, 3 spaces to the other side. So here's A prime. And then it says that we are taking that point and we're translating it 3 to the left and 4 down. So I'm going to take the image after the first transformation and I'm going to do the second one, the translation. 1, 2, 3 to the left. 1, 2, 3, 4 down. And here we have the point A double prime. It has the coordinates -5, -7. So that is the image of point A after both of the transformations happen to it. Moving on to the next one, and you might want to pause the video and try it yourself. Otherwise, the answers are just going to be displayed on the screen for you. So you might want to pause the video. This time we don't have a grid, so I'm not going to do these ones with a grid. It says we have triangle ABC with these vertices here. And under a translation, A prime, which is the image of point A, is located at 4, 4. Under the same translation, where will point C prime be located? So first we need to figure out what translation happened to get from A to A prime. Then once we know what the movement was, we can do it to C to get C prime. So A was 1, 3, and it tells us that A prime was 4, 4. So let's look at what happened. On the X coordinate, 3 was added. On the Y coordinates, 1 was added. So this is a translation of 3 to the right and 1 up. Now that we know the translation, we can apply it to point C. Point C was 4, 0. If we add 3 to its X coordinate, that's 7. And adding 1 to its Y coordinate, that's 1. And there we have it. Okay, the next says the image of triangle ABC under a translation is triangle A prime, B prime, C prime. Under this translation, B maps onto B prime. So let's figure out what that translation was again that happened. Because if we're going to have to use it in some way, we need to know what happened to get from B to B prime. So from 3 to 1, that's subtracting 2. And from -2 to -1, -1 is bigger than -2. -2 is more negative. -1 is bigger. So 1 was added. So this is a translation of 2 to the left and 1 up. -2, 1. So now that we know what the translation is, it says using this translation, the coordinates of the image of A prime is -2, 2. We need to figure out what point A was. So we're working backwards. So instead of subtracting 2 and adding 1 to each of the coordinates, we're going to do the opposite because we're working backwards from A prime to A. So instead of subtracting 2, I'm going to add 2. So -2 plus 2 is 0. And instead of adding 1, I'm going to subtract 1. -2 minus 1 is -3. It's getting more negative. Let's just test it out. If I apply the translation, -2, we do get -2. 0 minus 2 is -2. And if we add 1, -3 plus 1 is, oh, oops, this is a 2. My bad. I can't read my own handwriting. I thought that said -2. That's what happens when I write very sloppy. This is the 0.22. Okay, so instead of adding 1, we're going to subtract 1, so that's 1. There we go. And then if we're working the other way, 1 plus 1 is 2. So that works. We have found the original point A using the translation. Last one we're going to do for this video. You might want to pause the video and try it out yourself. So we have a table here, and the table is giving us some information so we can figure out what translation happened. So from A to A prime, because that's a complete one in this chart, it's the only complete section. 1 was added to the X coordinates, so that's 1 to the right, and 3 was subtracted from the Y coordinates, so that's 3 down. So to get from B prime to B, we just need to do the reverse. Instead of adding 1, I'm going to subtract 1. So that would be -6, because you're getting smaller than -5. And instead of subtracting 3, I'm going to add 3, so that would be 4. Okay, now here we're going from D to D prime, so we're applying the translation. So I'm going to add 1 to the X coordinate, so that gets less negative. And I'm going to subtract 3 from the Y coordinate. -1 minus 3 is -4.